Hi, this is Mrs. Basden, and today we're going to talk about how to calculate average atomic mass. So the average atomic mass is the average mass of all of the isotopes that compose that particular element. So we talked about how elements have different versions that have different masses, and those are called isotopes. So to calculate the average atomic mass, we are going to use a weighted average of those isotopes using their natural abundance. And the natural abundance just means what percent of that isotope does a sample of that element contain. A weighted average is used because then the average mass is represented by the isotope that's in greatest abundance. So when we calculate the average atomic mass, we're going to take mass times percent abundance of all of the isotopes for that particular element. So mass times abundance of the first isotope plus mass times abundance of the second isotope. If there was a third, a fourth, a fifth, you would continue to do that. And then we're going to divide all of those by 100. So because we're leaving the abundance as a percentage, we're going to divide by 100 to get our final average atomic mass. The data that we're using to calculate these average atomic masses comes from something called mass spectrometry. So when they have a sample of an element, they run it through something called a mass spectrometer. And what that does is that separates the samples into particles according to their mass. So that's what gives us the different masses, and it tells us what percentage that particular isotope is of a total sample of that element. So we'll talk a little more about this in class tomorrow. We'll watch a quick video that kind of explains it. But basically what happens is the sample goes in, it becomes ionized, then it accelerates it, and a magnetic field separates those particles into their different masses. So then when they come out on the other side into the detector, they're separated out lightest to heaviest. And then we can then interpret that data to give us the percentages that we use. So you're not going to have to do anything with the mass spectrometry piece of this because we're going to use the data that's provided as a result of that particular experiment. So we're going to go through and do a couple examples together here. Then we'll do a couple more examples in class, and then we'll do some practice in class together. So the first one we're going to look at is gallium. So gallium is a metal. It's kind of a weird metal because according to the standard, it's considered to be solid at room temperature, but it has such a low melting point that if you hold gallium in your hand, it will actually melt from the heat of your hand. So gallium has two naturally occurring isotopes, gallium-69 that has a specific mass of 68.9256 AMUs and a natural abundance of 60.11%, and gallium-71 that has a specific mass of 70.9247 AMU and a natural abundance of 39.89. So what we're going to do here is we're going to calculate the average atomic mass of this particular gallium isotope. So when we do an average mass calculation, we're going to take mass of the first one times abundance plus mass of the second one times abundance. So in this case, we only have 2, and then we're going to divide by 100. So for this first one, it tells us it's gallium-69, but because it gives me a specific mass, that's what I'm going to use in my calculation. So 68.9256 times an abundance of 60.11 plus the specific mass of my second one, 70.9247 times the abundance, which is 39.89. And notice the abundance always equals 100%. So if there's two samples, the two percentages are going to equal 100%. Then we're going to divide by 100 to get our final answer. So for this one, and I'm going to move over here a little bit so we can see the answer. When I calculate that, mass times abundance plus mass times abundance divided by 100. I'm going to round these to 2 decimal places because that's how we're going to take those numbers off the periodic table. So I'm going to call my average mass 69.72, and the unit we're going to use for these is AMU, atomic mass unit. So the average atomic mass of gallium is 69.72 AMU. The nice thing about this, because we're using real data, you can actually compare that to the red number on our periodic table in the classroom, and it should be really, really close. It may not be exact, but it should be very close. Okay, let's try one more. So for this one, magnesium has 3 naturally occurring isotopes, and we use magnesium a lot in the labs that we do in here. So the 3 masses are 23.99, 24.99, and 25.98 AMU, and then the abundances are given as 78.99%, 10%, and 11.01%. So we're going to calculate the average atomic mass. So again, mass times abundance. So they have them listed in order. So 23.99 times 78.99. So that's my first one, plus second one, 24.99 times 10, plus third one, 25.98 times 11.01. And I'm going to divide all those by 100. So again, mass times abundance of the first plus mass times abundance of the second. Since we have a third one this time, mass times abundance of the third, all divided by 100. We're going to round to 2 decimal places again. So 24.31 AMU is our average atomic mass of magnesium according to this data. Again, check those numbers. It should be really close to that average mass that's listed on your periodic table.